Yeah, hello everyone. My name is Xiaomian. This presentation will be a joint effort from me and also Richard Lowe from AECOM. Just a little bit of background about myself. I joined ISSE over 8 years ago now. After completing a PhD on biomass combustion at the University of Leeds, and my main role at ISSE is to identify new opportunities and also provide technical support to new and innovative projects. Move on. Yeah, just a little bit background about CCS projects in ISSE. I'm sure you are aware of. I just like to highlight that the Fairbridge pilot plant, 100 ton of CO2 capture a day. That was the first of its kind, which is integrated into a live power plant in the UK. Then Peterhead feed, it was designed for 1 million tons of CO2 capture a year. It would have been the world's first commercial plant of its kind. Even though it was cancelled, but the project itself provided an excellent knowledge sharing platform. And all key knowledge deliverables are available on the government's website. And then ISSE now developing KB3 and also Peterhead 2. They are full-scale CCGT and CCS projects with up to 2 million tons of CO2 per year capture. Again, this project will be the world's largest commercial plant of its kind when built in 2020 to 2030. I just would like to show you the location of the KB3 project, which is adjacent to current operational plant KB2 and also new CCGT KB2, sorry, which is under construction. And then move on. In terms of air emission studies, I'd like to present the due to involvement and ISSE investment in those innovative projects. We've built abundance of knowledge with this area. Due to limited time, I won't go into detail of learnings from Fairbridge and Peterhead. But in KB3, we took all the lessons learned from those previous projects, and we go further. We have direct contact and engagement with research and research centres such as Technology Centre Munstad. We commissioned a number of studies on solvent degradation, emission reduction, and abatement technology. And we also commissioned a week-long test campaign at the TCM to understand emissions from the absorber stack. We also started a planning process with help from AECOM due to their expertise within this area. We are working towards a final DCO submission. On top of that, we are really working very closely with supply chain to make sure the project is designed with the most advanced technology, and it will be a world-class project when deployed. Okay, these are our findings and conclusions. Emissions can be prevented and reduced in a number of ways, as I highlighted here. I won't go into detail due to the limited time for this presentation. And an emission abatement system also available, such as water wash, demister, and also acid wash can be added to the system if needed. And also stack emission monitoring, online measurement tools are also very important. just as a overall, as our conclusion, from SSE point of view, that we are confident there are technologies available which allows us to manage and control the stack emissions to a level which is acceptable for when you're concerning the environmental impact. That's it from me. Just try short time to give you an overview from what SSE's work so far in terms of emission. I will hand over to Richard Lowe. I think he's online. He will give you an inside view on what's happened when certain species enter the environment. Yeah. Richard, did you want to come online? And
sorry about the brief hiatus there, but thank you, Xiaomian, and Jessica. Likewise, I think a lot of the points you made are very pertinent. Certainly, we've been obviously working alongside yourselves and the Environment Agency to try and resolve some of the issues around assessment. And as per this slide, so one of the issues, of course, that has certainly came up through the Peterhead project originally, but we're still exploring, is the degradation of the amine in the carbon capture process. And we've got direct formation and release of the amine through the absorber stack itself, and some of that's captured through a wash water step, but some of it will still pass through. We've also got degradation of that amine within the process, and some of that is liberated as a degradation product. And that's either as the form of ammonia, but also these nitrosamines, nitramines, or NAmines is a sort of generic term, and they get released as well. As well as that, once the emission is dispersed into the atmosphere, there's further atmospheric chemistry to further react the released amines and form NAmines downwind of the stack. And that's one of the key areas of uncertainty, I think, in terms of the assessment. It's really the CRC chemistry module, which I think maybe being talked about after this presentation as well, is a useful tool to try and quantify that, but it's obviously a complex reaction, multiple reactions, and relies on a lot of assumptions, which then probably need a bit more work to resolve. So if we go on to the next slide, please. It should be emissions of ammonia. Yeah. Great. So this is an important learning, actually, from the recent projects. We're working on a number of carbon capture projects in the UK. And while there's some very good expertise, and from a global perspective, TCM, Boundary Down, Petronova, etc., none of them have really had to face and address the emissions of ammonia and the formation of ammonia as part of those projects. And this is very much a UK focus. And so just very briefly touching on that. So this has largely been driven by ecological habitat impacts and effects. So looking at internationally and nationally designated sites, SSIs, SACs, SPAs, etc. So when we look at emissions from the process and the formation of ammonia, this can lead to nitrogen deposition on those habitat sites. So we have to consider the critical levels, which are the direct air quality concentrations, and then there's also the critical loads, which is the nitrogen deposition. And ammonia has a much higher deposition rate than nitrogen oxides. So we have the rather challenging position where, certainly from a gas-fired power station, removing the NOx from the emission is important to meet the limits and control NOx emissions as a whole. That's usually done through the use of selective catalytic reduction. That in turn liberates some ammonia slip, which then gives rise to a nitrogen deposition challenge. So the two work against each other in that sense. So one of the aspects is to address this ammonia emission, and this is something that's quite a recent challenge. Xiaomian has already touched on one aspect, which is a good way to address it through the use of what's called an acid wash. But I think that's certainly what appears to be John Gibbons' work is looking at designating that as best available technique, and I think that's sensible because it's a way of addressing this issue. But it is then leading to further issues down in terms of the life cycle cross-media effects, if you like. So it addresses the air quality issue very well, but then leads to a waste, which then needs further consideration. So the work on this is evolving, I would say, but there is a good solution, but it is a solution that then leads to further challenge. And we'll come back onto that. So if we go on to the next slide, please, which is the nitrosamines, nitramine slide.
Yeah.
So I don't think, thank you. I don't think we need to say too much on this because I think Jessica's presentation covers this very well. But I think what it's shown is that we've got an opportunity to use the ADMS module to try and provide some estimation of this formation pathway. But clearly that is a tool, and as Jessica said, the inputs to that determine the outputs from it. Obviously, also it's parameterizing and simplifying the reaction rates. So I guess one question for the research community, when I did my PhD some years ago on atmospheric chemistry, we were looking at ozone formation downwind of the plume. And there we were using a number of different chemical mechanisms, and we were trying to develop a fast chemical mechanism solver at the University of Leeds. And I almost think we need to have a look at that as an opportunity as well. I mean, in Norway, the University of Oslo have a chemistry module which they use for this, and it's whether something equivalent is perhaps considered as a research tool to support the inevitably and deliberately more simplified approach undertaken through the ADMS module. So looking at the photolysis effects, looking at nighttime reactions, looking at hydroxy radical formation pathways, and using that. So I think that would be something that I would think would be quite interesting. If we go to the next slide. So just a couple of points here on the research needs, which I haven't listed that one, but through that conversation and through Jessica's presentation, I do think that's something to consider. But the other one is the cross-media effects of the acid. Is a better acid available than the sulfuric acid, which is the current default position, if you like? And what are the formation of, what about the acid release as well as the other releases, and whether that have any bearing on environmental effects. And then the nitrosamines, nitramines, I think there are a couple of issues here. I think at the moment, a lot of the assessments very much are inevitably and deliberately conservative to provide a worst case. But actually, how much longevity is there for these species in the environment? Because I think some research I've seen, some research papers indicate relatively short lifetime, which is really helpful and positive because it starts to put the issue into perspective rather than becoming a major challenge for some stakeholders. And also, there's a wide variability on their toxicity, and we've got some toxicity data, and I think John's mentioned some of the challenges around environmental assessment levels. But I think taking a precautionary approach is the right thing to do to demonstrate that the industry can achieve what's required. But actually, I think we possibly are being overly conservative, and in actual fact, this issue might not be as significant as it could easily be portrayed. So I think those are some areas around the toxicity and the longevity of these species to try and put those into perspective when consenting and developing carbon capture processes. So I think that's everything from me. Sorry about the technical challenges at the front end of that, but hopefully that's been of use.